The final clip, I'm going to look at just some language that comes with a bit of concept behind. Could have maybe started with this, but perhaps by now we're more ready to think about it. 3 terms: true probability, theoretical probability, which we most commonly use probably, and experimental probability. Now, true probability, I'll go through the definitions and then we'll look at the example I've got, and then we'll leave you to have a crack at some questions to make sense of it. But true probability is all the factors involved, and we don't usually know. It's a little bit of a live by faith sort of principle. The world is a tricky place, so all the factors involved in leading to an event. Theoretical probability is when we use a model. And we do this all the time in probability, and they're based on assumptions. And they give us, model estimates for probability. We do a lot of assuming when we do theoretical probability. Experimental probability comes in 2 ways. Simulations, where we run a situation a whole lot of times, or a simulation. That simulation will also be based on assumptions. You can't set up a simulation without doing that. And it'll lead to an experimental estimate. The other way you can do this, and it's not really an experiment, and this is what insurance companies do, is you can just collect a whole lot of data to make your decisions, your probability decisions. The insurance industry, that's why young people pay more or have higher excess for their car insurance. It's historical. Blame that on the boys. It's clearly their fault if you dig into it. So the example I've got is gender. Now, gender at birth. Gender is decided as a rule before birth. There's a thing called gametes. But we'll just assume in practice, if you're a parent, we'll look at it from that angle. It's not something we control. We don't really know all of the things. There's chromosomes involved, and so actually what's controlling that is something a little bit beyond us, and that's fine. It's maybe one of the mysteries of the world that should stay a mystery. But theoretical probability, we make assumptions. Now, not all these assumptions are right, but they're sort of right in a crude, broad sort of sense. When we're talking about gender, we tend to say, oh, well, it's a half-half split. And so that's the major assumption. Now, that ignores some people for whom, physically, that's not quite so straightforward. If you follow the news, and I'll flick on the screen, there's this lady here, Caster Semenya. If you read her, Caster Semenya from South Africa, very good athlete. If you read her background, you'll get an interesting angle on that. So theoretical probability makes assumptions, and the assumption in this case is quite a broad one, and so then we would use it. So what's the probability if you have a 3-child family that you have 3 girls? We would go, oh, well, that's a half times a half times a half. And that's a 1/8 probability. We're assuming that one child is independent from the other, and then that's what you would get. So that's a model estimate, is the half. Now, that's only an estimate, and it's based on some assumptions. If we're doing something with experimental probability, say the same problem, what's the probability that a 3-child family has 3 girls? We would use similar assumptions, and maybe we would go heads and tails, tossing a coin 3 times and record it. We might do it on a spreadsheet. Regardless, we would just repeat it a whole lot of times, selecting 3 children in a row, and we would keep track of how many 3-girl families there was out of the total, and we'd use that for our probability. If we were going to do it based on data collection, we'd just go around the country, find all the 3-child families we could, and ask them, do you have 3 girls? And we would build a probability based on that. And so none of them are actually perfect. There's various things we could critique in them, but they give us, in the world of probability, we're working on the process of sort of sensible guesses rather than deadly precision. And a few things to keep in mind. Simulations and collection of data, we assume that the larger the number of trials or the more data we collect, the closer we should get to the true but unknown probability. That's what we hope. If our assumptions are reasonable, then with a large number of trials, we would expect an experiment to be close to the theoretical. We would expect them, and that's because both theoretical and experimental is based on assumptions. If we get those assumptions right, the two should ultimately come together if the experiment is big enough. Probabilities using simulation or data collection are referred to as observed. What we've seen, probabilities based on theoretical models can be referred to as expected. So comparing observed to expected in a long run sort of probability situation is something you might be asked to do. Okay.